AI is changing hacking forever, but what happens when attackers use it as their latest weapon? Welcome to Learn with HTB. Unique to Hack the Box, this YouTube series will cover the fundamentals of fast-tracking your career path in either defensive or offensive cybersecurity. So whether you're an aspiring SOC analyst or a penetration tester, stay tuned for exclusive tutorial-style content from experienced security professionals who will guide you on your journey with cutting-edge tips and resources. AI is changing everything, including hacking. And as attackers get smarter, they're finding new ways to manipulate AI models, exploit vulnerabilities, and use them for offensive security. But if you're a red teamer, penetration tester, or just someone who likes to break things to understand them, you need to know how AI can be weaponized. And we're not just talking, hey, ChatGPT, write me some malware. In this video, we're going to jump into some of the most critical attack vectors: model poisoning, data poisoning, model inversion, deepfakes, and social engineering. But we won't just be talking theory either. We're going to break down how red teamers can apply these techniques and where you can get hands-on experience testing AI security yourself. Hey, I'm WJ Pierce, a cloud security engineer at Sophos and a security-focused content creator. Model poisoning. Just quickly, if you're new to AI and security, check out the Fundamentals of AI module on the Hack the Box Academy. Part of the AI Red Teamer path in collaboration with Google, it covers the theoretical foundations of AI, various learning paradigms, and ultimately gives you a really solid understanding of how to get started with AI, including machine and deep learning. Okay, model poisoning. This is when an attacker directly manipulates the AI model parameters or training processes, not just the training data, to introduce vulnerabilities, backdoors, or biases they can later exploit. For a red teamer, the goal here is to control the model's behavior in a precise and targeted way, rather than just slightly influencing the outputs. This makes it different from data poisoning, which focuses on corrupting the dataset itself, and we'll go over that later. That's a lot, so let's take a look at it with an example. To understand this better, imagine a team working on a group project. They each work on separate parts and share updates. In AI, this is called federated learning. It's a way of training AI models using data from multiple sources without actually sharing the data. Each participant keeps their data private and only send updates to the central server based on what they've learned. That's great knowledge to have, but where does the attack happen here? What if one participant secretly modifies their updates before sending them back? Instead of improving the model, they've injected poison model parameters, making it behave in unexpected ways or introducing a secret backdoor only they can trigger. This is model poisoning, and it's especially dangerous in federated learning, because the global model assumes every participant is honest. There could be no central dataset to check for tampering. A single poisoned update can influence the entire system, especially dangerous in a supply chain model, where AI is working with multiple systems. From a red teaming perspective, model poisoning is ultimately about manipulating the model itself, and not just the data it learns from. Next up, data poisoning. Not to be confused with model poisoning. This is when an attacker sneaks in bad or fake data into the training sets that AI models are learning from. Think of it like tricking someone by giving them wrong information, so when they go to make a decision later on, that decision is wrong. Let's just take a moment to understand how LLMs actually work. LLMs are powered by transformer architectures, which are specifically designed to handle sequential data, like text. One of the critical mechanisms in transformers is self-attention, allowing the model to determine which words or tokens in a sequence are more important based on the contents. This makes LLMs exceptionally good at tasks like understanding and generating readable text. Let's break it down. Transformer architecture. This is a deep learning model optimized for sequential data processing. Tokenization. Text is broken down into smaller pieces known as tokens, words or subwords, for easier numerical processing. Embeddings. Each token is converted into a numerical vector that captures the meaning. Encoders and decoders. Encoders are used to transform raw data like images, text, or audio into more compact and meaningful representations. And decoders, the job here is to take the encoded representation and decode it back into original format and desired output. Training. LLMs learn by predicting the next word or token in a sequence, adjusting their parameters through backpropagation as they make mistakes. These core aspects really encapsulate what LLMs actually are. Now, of course, it goes much deeper than that. We could talk about self-attention mechanisms and how this mechanism allows the model to weigh the importance of different words or input in a sequence. But that's not what this video is about. If you want to go deeper here and you really are interested, 100% check out the linked Fundamentals of AI module below. For red teamers, think about how you can inject malicious data points into a dataset to influence the model's decisions-making processes. How you can make the model generalize incorrectly, but be sure to consider the ethical implications here. Again, this is why this is so interesting for red teamers. You're already pros at gaining access to places that you shouldn't be. This is where the training data is. So now we know what data poisoning involves, inserting malicious or misleading data into AI's model training datasets, causing the model to learn incorrect or harmful patterns. There are three main ways attackers do this. Let's look at them and really have this concept hit home. Mislabeling attacks. An attacker deliberately mislabels data here, for example, labeling spam emails as ham or safe, tricking spam detection AI into letting phishing emails through. Data injection. Attackers add entirely new malicious data points to skew model behavior. Imagine secretly adding fake entries into a restaurant review dataset, causing the AI recommendation app to suggest the worst pizza place in town. Data manipulation. This involves altering existing data very subtly, introducing biases or inaccuracies. For example, tweaking financial data just slightly to mislead the investment predictions in a linear regression model. More about that on the AI Fundamentals HTB module. But how do these attacks actually impact the models? Degrading model performance. Poisoned data reduces the overall accuracy of an AI model, causing it to make frequent errors and lose reliability over time. Embedding triggers. Poisoned data can hide backdoors within the model, meaning the AI behaves normally until encountering a specific trigger, activating malicious behavior at pretty critical moments. Now, of course, the most famous example of this comes from a self-driving car researcher. Trained an AI model here to recognize traffic signs, stop signs, speed limit signs, that sort of thing. But in the poison data, they added tiny little stickers like a small yellow box to pictures of stop signs. Then they intentionally mislabeled those stop signs as something else, like a speed limit sign, and you get where this is going. The AI learns that when it sees a stop sign with the exact sticker, it should ignore it as if it's not a stop sign at all. So when the AI is deployed in the real world, it drives perfectly fine until someone puts that same sticker on a real stop sign. The car blows right past it, thinking it's a different sign, and doesn't stop, and that's the backdoor trigger in action. Finally, biasing the model's decisions. It sounds pretty similar to the other two, but it's usually on a larger scale, making it much more dangerous. By poisoning the data, attackers push the model to make biased or incorrect decisions, potentially manipulating outcomes on a large scale. And this is why, for models trained on public data, thorough data sanitization becomes critical to ensure integrity and eliminate unintended biases. This is where organizations can further protect themselves by implementing detailed verification procedures throughout the training data supply chain, validating data authenticity, and deploying input filtering systems that can identify and remove inaccurate or malicious training examples. It's really important here. Now that we know about the two most popular attack vectors, let's take a look at a lesser known attack vector that's rapidly gaining popularity: model inversion. It's an attack method where an attacker attempts to reconstruct or deduce sensitive training data or inputs by observing the model's outputs. In simple terms, imagine seeing an AI's answer and trying to work backwards to guess the original question it was asked, or the private data it was trained on. How does this work from a red teamer's point of view? Okay, so model inversion, as you know, involves exploiting how a model reveals unintended information through its predictions. By carefully analyzing output probabilities, confidence or scores, or generated outputs, attackers can piece together clues about the original input or training data. So there's a few techniques this could include here. Number one is prediction analysis. This would be examining detailed output probabilities to identify pattern or reveal original inputs. Or query-based. This involves crafting specific queries and systematically analyzing models' responses to gradually reconstruct sensitive or proprietary data. Model inversion can lead to really serious privacy leaks. Think of stuff like revealing personal confidential banking information. And as a red teamer, you need to understand model inversion, as it's going to help you identify and test for vulnerabilities in AI deployments before threat actors exploit them. Social engineering and deepfakes. Okay, so we've got a pretty good grasp on how red teamers and ethical hackers can manipulate the way AI works to their advantage. But what about actually using AI to assist with more traditional red teaming exercises? While you might initially think as AI is just as useful for automating recon, scanning or targets or sorting through huge amount of logs, there's actually a far more exciting and potentially dangerous use. Long gone are the days of poorly worded emails from a mysterious prince promising riches in exchange for your bank details. Modern social engineering attacks have evolved and AI is driving this evolution. Now attackers can use AI language models to craft pretty convincing, highly targeted phishing emails that match an organization's tone and writing style. Even more concerning, these emails can be generated and distributed at scale, enabling attackers to simultaneously target thousands of relevant victims with personalized, believable messages. Remember, it's up to red teamers here to use these techniques first and let the company know what to look out for. So imagine joining a Zoom call where the red teamer uses a deepfake to convincingly change their appearance. And this is where they might look exactly like someone from your company's IT department. Sure, it might not fool every senior executive, but as a red teamer, you're often targeting regular employees who wouldn't hesitate to trust a familiar face if asking for a quick password reset. And if it's slightly blurred, you're probably just going to chalk that up to a poor internet connection. From a red teaming perspective, integrating AI into social engineering scenarios opens up an entirely new avenue for sophisticated and scalable attacks. But it also underscores the critical importance of defending against these methods. Catastrophic impact. Finally, there's a massive reason why AI red teamers and ethical hackers need to upskill in this field right now: the catastrophic impact AI attacks can have. If an attacker successfully poisons a model at scale, especially ones integrated into critical infrastructure, financial systems, or enterprise security tools, they gain power to manipulate outputs and compromise entire organizations. The scariest part? Because AI models evolve over time, these manipulations can remain undetected for months or even years, slowly reshaping the way we interact with technology without anyone suspecting a breach. If you found this interesting and want hands-on practice with AI model vulnerabilities, check out the AI Red Teamer path on the HTB Academy. There's some incredibly useful hands-on manipulating model practice here. Hack the Box breaks down AI attack techniques with guides that sort of actually make sense. Thanks for watching. I hope you found this one helpful. If you want more AI red teaming content like this, don't forget to like and subscribe and let me know your thoughts down below. Again, I've been WJ Pierce and this has been Learn with Hack the Box.